We've partnered with the engineering group at the University of Arkansas in Fayetteville to learn more about using digital aspects to gauge the ripeness of the blackberries.
Back in 2020, when we initially developed a robotic gripper, we relied fully on intuition. So we're like, hey, let's make a soft compliant system that can harvest this delicate fruit. And that didn't really dive into the core questions of what is needed to harvest the fruit, how much force is needed, how much force should you apply to that berry depending on how you apply it.
These blackberries are commercially harvested by hand all over the world. If we are going to increase the amount of blackberries grown, how can we help with mechanical harvesting in some way, shape, or form?
In order to analyze that detachment force, we needed to make something that could measure that detachment force. The thought process behind this was to develop some sort of gun, so to speak, that had a linear carriage on it that only permitted motion in the direction of that linear carriage. And so in addition to that linear carriage, we mount that to a force sensor. And so when we clasp onto the berry and pull on it, that force sensor is the only thing restricting motion, and that will tell us what is that detachment force.
What we want to get to eventually is to possibly have a robot that has a brain, it has eyes, it maybe have arms that can harvest a fresh market blackberries.